So here we see again with the Monochrome OLED, the same Seattle Robotics Surface Mount class board from last February. We'll go ahead and flip this on. Remember, from the color OLED display, we scrolled into color image and then monochrome image and some shading. So here's that same image just now as a monochrome, and the same SRS logo, of course. You can see it scrolling in some text. You can almost see the word KIT under there. It's a different shade of yellow. And we're going to do a fade, and now we can show its clock and battery voltage in small text. So you can see, again, examples of using images. In this case, they're 4-bit grayscale images for both cases, and both small and large font text. Yeah. I don't video enough to warrant a video tripod, but so here we can show you again what it looks like when we adjust the pot here attached to the analog pin. So in this one, the battery shows dead in the center. It kind of shows you how small of a pixel. I think that's a 4x4 pixel by 4 pixel font, and it's obvious what it means when you see it. So you can kind of see the same shading that I have on the color. Was using on the color. It's actually the same image, where it's a little darker on the bottom, brighter on the top. And if you adjust the contrast a little, you can see things a little bit better. The refresh on this is much faster, but it has to draw many fewer pixels, or much less data per pixel than it does for the color. The color is drawing at 16 bits per pixel. Yeah, 16 bits per pixel. It's in a 565 format. 5 red, 6 green, 5 blue. Whereas this is 4 bits per pixel. So actually it's drawing 2 pixels at a time for each 8-bit byte out the SPI port. So it can actually get a pretty decent refresh rate on this. I haven't measured it in a few years, so I can't say really offhand what you could get full frame, but there isn't really a whole lot of storage space, so it's not like you're going to be showing videos. Let's see if we can see any of these other little mods on here clearly from this angle. As you can see, I had this in a different orientation from the color, mostly because I was debugging the color one in bed, and it was easier to see for me to see it in the other orientation, so I just flipped the bit to tell it to flip orientation. The monochrome works the same way. So here you can see where I cut the lead from the battery to go to this power switch. Well, the lead from the battery charger, I should say, out to the 5-volt boost regulator, which then is the power switch. You can see that the 12-volt boost is also running, so I have all 3 power LEDs running on. You can see I actually do have both the monochrome and color OLED headers on this board. You can obviously only use one at a time, since they both use the same chip select line for the SPI port. And you can see buried under here is another pin header, and that's for that SPI port expander for just standard character LCD, which you could use at the same time as any of the OLEDs, or you could just use it as an additional I/O or just on its own. You can see the ISP header gets in the way of all the OLEDs. It doesn't usually bother me because I'm usually using the JTAG, but the JTAG gets in the way of this OLED anyway, just because this OLED is so wide. This again is 128 by 64. The color is 160 by 128. You do a little math, you can realize that there isn't actually even enough memory on the 32U4 in flash space to hold an image that covers the entire color display. I'll have to cut this video short about now, because pretty soon this tiny little battery is going to die. I did find a battery from an old iPod mini Gen 3 or something that my wife had that died probably 5 years ago. And maybe I'll hack that in and see if it has any more oomph to it than this very abused cell. We'll go ahead and reset it once so you can see that whole opening again, because it's kind of cool. Oh, no, never mind. You can see as the battery dies, it starts flashing. In theory, this board can run off the USB power and 12-volt power and charge the battery at the same time, but I don't have the current limit set right to actually do that. I do have a USB cord right here, though. We can go ahead and plug that in. So you can see the charge light's lit. The USB port plugged in. And actually, when it thinks the battery's fully charged, that light will go out. Oh, there's that same color image, this time at grayscale, 4-bit. It's actually the same size, 64 by 64, as it is on the color, but you can see the difference in pixel size between this and the color display that way. Night.